Hello again. So this micro lecture is on component vectors. As always, you need 3 or more bullet points worth of notes, a 1 to 2 sentence summary, and your follow-up questions on Google Forms. Now, I know we might be switching modes a little bit here, but we've been really applying this concept of component vectors and another concept. So we really want to kind of formalize our knowledge about it so that we're aware of what's been going on. So we're familiar with this idea that this arrow represents a vector. Normally I'd have a value here to tell me how much or how long this is, but we could also base it on the length. But what we maybe don't realize is that vectors, in other words like this one, can be broken down into kind of parts or components to this vector. The first component that we can talk about is how far sideways it's moving. This would be called, or how far sideways it goes. This would be called its x component. So if we have this vector right here, we can see that it actually goes sideways this amount right here. And that kind of lines up. So you can think of it almost like a vertical shadow or something like that. But we can also break something down, or a vector down, into how much up and down it goes. So in other words, the y component. This applies to distances, this applies to forces, and anything else that is a vector that we deal with. You can break it down into its x and y components if we're working in 2 dimensions. If we had 3 dimensions, you could break it down into its x, y, and z components, like how far back into the page it went, or something like that. So to calculate these components, for example, if I have a vector value of 6 and it's at 60 degrees from the horizontal, we can actually figure out the kind of sideways component value, or the x component length, as well as how much it has in the y direction. We've already talked before about how to add these together. We're now going to figure out how, once you've maybe gotten something where they're added together, how do you break it back apart? And really you can do this using sine, cosine, and tangent as necessary, depending on which angle is being given to you and things like that. So to do this, what we're going to first do is you're going to want to move your y vector over to here, just so that you can see the triangle a little bit more clearly. So by doing that, we can see there is a triangle here, and it's still the same vector, kind of tip to tail addition right here. And based on this, we can now go, hey, it's a right triangle, and now I can use sine, cosine, tangent much easier. So we've done that, and now it's just a matter of, okay, well, if we want to figure out the y component, then in this case, it's going to be using sine, since sine is opposite right over here from our angle, divided by the hypotenuse. So we'd plug those values in. We don't know the value of y, but we do know the hypotenuse is 6, so I'd plug that in. And to solve, you would multiply both sides by 6, which gives you 6 times sine 60, and you'd solve that and figure out that y equals 5.19. If you wanted to do the x component, you do the same thing, but this time you're using the adjacent side compared to the hypotenuse, and that's cosine. Equals adjacent over hypotenuse, or SOHCAHTOA, to help you out with that. In this case, we don't know the value of x, so we plug in x as just a variable. We do know that the hypotenuse is 6. You plug in, you multiply both sides by 6 to get the x by itself, and that gives you that this is a value of 3 for the x side, or the x component of this. So what that means is that we have a side of 6, a side of 5.19, and then a side of 3. And these two combine to make that 6, or the resultant vector. Now, components can also be added together to make a resultant vector. So in this case, if you have x and y components, then you can, such as let's say 5 and 3, they can be added together using Pythagorean theorem as we've done before, and the result in this case would be 5.83. So just a little reminder on that since we've talked about it. But these component vectors are going to come in handy when we start talking about 2D motion. That's it. 3 or more bullet points worth of notes, so 1 to 2 sentence summary. Please do your follow-up questions on Google Forms.